Hello friends, till now we know that parallelograms on the same base and between the same parallels have equal area. And also that the area of the triangle which is on the same base and between the same parallels as a parallelogram will be half the area of the parallelogram. In this video, we are going to place two triangles between two parallels and see what that unfolds. So let's start by considering the triangles ABC and PBC. Now, these two triangles satisfy the two important observations that we are discussing throughout this chapter. That is, both of these triangles are on the same base, which is BC. And both of these triangles lie between the same parallels, that is, between BC and AP. Now, what if I tell you that even though these two triangles may not be congruent, but they have the same area? Confused? Don't worry. I won't leave you just with that statement. I am going to prove it. But further, we need to perform a small construction. From the point C, draw a line segment CD such that the line segment CD is parallel to AB. Now, we have a parallelogram ABCD. Observe that both the triangles ABC and PBC are on the same base and between the same parallels as the parallelogram ABCD. Now, what does that mean? We know that if a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is half of the area of the parallelogram. So, we can conclude that the area of the triangle ABC is half the area of the parallelogram ABC. Also, for the same reason, the area of the triangle PBC will be half the area of the parallelogram ABCD. From this, we can clearly see that the area of the triangle ABC is equal to the area of the triangle PBC, since both their areas are half the area of the parallelogram ABC. There you have it. We proved that triangles on the same base and between the same parallels are equal in area. I have a question for you. While constructing, why did we construct a line parallel to AB? Why not parallel to PB? Well, we could have drawn a line parallel to PB2. In that case, we would have observed the parallelogram PBCD instead of ABCD, and that too gives us the same result. In fact, we could have taken any point out of A, B, C and P for the construction. Why don't you select your combination and try to prove the same? Now, can you prove the converse of this theorem? That is, two triangles of equal area that are on the same base and with the third vertex on the same side of the base lie between the same parallels. Pause your screen and try to prove this theorem. Done with the proof? Let me do it for you so that you can check it. First, let us understand the statement. The statement says there are two triangles of equal area. So, let's say these are the two triangles of equal area. The next part of the theorem says two triangles have the same base. So, these two triangles must be having the same base like this. Finally, it says that the third vertex must be on the same side of the base, which implies that the second triangle cannot be like this. Why? Because we have to prove that both these triangles lie between the same parallels. Now, if the vertices are on the opposite side of the base, then that will contradict our basic definition of shapes between the parallels. So, the vertices must be on the same side of the base. As we have understood the statement, now let's start the proof. First of all, there are two triangles with the same base and equal area. What we have to prove is they must lie between the same parallels. Now, how can we prove that both these triangles lie between the same parallels? We know that the perpendicular distance between the two parallel lines is always the same. Now, if you can prove that the heights of these two triangles are equal, then it is proved that these two triangles lie between the same parallels. Now, our aim is to prove that the heights of both these two triangles are equal. So, how will we do it? So, let's consider the length of the height of the triangle ABC to be H1 and the length of the height of the triangle DBC to be H2. Since both of these triangles are on the same base BC, let's consider the length of the base to be B units. Now, it has been mentioned that the areas of both these triangles are equal. And we know that the area of a triangle is half multiplied by the length of the base multiplied by the length of the height of the triangle. So, the area of the triangle ABC will be half multiplied by B multiplied by H1, and the area of the triangle DBC is half multiplied by B multiplied by H2. Since the area of the triangle ABC is equal to the area of the triangle DBC, we can equate half B H1 and half B H2. So, from this, we can clearly see that H1 is equal to H2, which implies that the heights of both these triangles are equal. That's it. The heights of both these triangles are the same, which implies that both these triangles are between the same parallels. So, we have successfully proved this theorem. Now, let's check our understanding of the concepts we discussed today by solving a simple problem. In this problem, we have to show that the median of a triangle divides the triangle into two triangles of equal area. So, let's do it. Friends, first of all, what is a median? The median of a triangle is a line segment joining the vertex and the midpoint of the opposite side. There are three medians in a triangle. For example, in the triangle ABC, if AD is the median, then the length of BD will be equal to the length of DC, since D is the midpoint of the line segment BC. Now, our aim is to prove that the area of the triangle ABD is equal to the area of the triangle ADC. Observe that for both the triangles ABD and ADC, the height will be the same, since the height is the perpendicular distance from the vertex A onto the side BC. Also, since AD is the median, BD will be equal to CD. Now, let's shift the triangle ADC to the right side. If we do so, we can clearly see that DC will coincide with BC since both of them are equal. Now, let's draw a line parallel to BC passing through A. We can clearly see that it will pass through another A as well. Because as we proved earlier, the height is the same for both these triangles, which implies that the distance between this new line and the line segment BC will always be constant, which implies that these two lines are parallel to each other. So, what do we get now? Yes, we get two triangles which are on the same base and between the same parallel lines. And what do we know about such triangles? Yes, you are right. Their areas are equal. So, we proved that the area of the triangle ABD is equal to the area of the triangle ADC. From this, we can conclude that the median of a triangle divides the triangle into two triangles of equal area. So, we have successfully completed our problem. So friends, that's all for today. In our next video, we'll solve some problems related to these concepts. Before we end our video, let's quickly summarize what we have learned so far. Parallelograms on the same base and between the same parallels are equal in area. The area of a triangle which is on the same base and between the same parallels as a parallelogram will be half the area of the parallelogram. Triangles on the same base and between the same parallels are equal in area. two triangles of equal area with the same base and the third vertex on the same side of the base will lie between the same parallels. The median of a triangle divides the triangle into two triangles of equal area.